Hello, everyone. Welcome to TML Summit virtual session. My name is Savik Roy, and I will be the moderator for this workshop. I would like to introduce our presenter, Alex Kim. Alex Kim is a solution engineer at Iterative. His background is in physics, software engineering, and machine learning. In the past couple of years, he became increasingly interested in the engineering side of the ML side projects, processes, and tools that need to go from an idea to production solution. Thank you. Over to you, Alex.
All right. Hello, everyone, and thank you for joining this session. I know for some of you, this may have been a long day. So I specifically designed this talk to be kind of not super technical so that you don't have to stress out at the end of the long day. Right. So today I'm going to be talking about machine learning experimentation with DVC and VS Code. So many of you may have heard about DVC being a tool simply for data versioning, but there's a lot more to it than just data versioning, as we'll see in this talk. So let's start with kind of just to set the stage. We'll start with a problem. Imagine that you work at a bank and you've got your hands on a data set of customers who stayed with the bank and the ones who left, and you've got some features describing individual customers. And we want to train a model that can potentially predict whether customer is likely to churn or not. And then if we can use this model in the business setting, that means we can identify potential customers who are about to leave us and maybe do something about it, because as most businesses know, it's much cheaper to retain existing customers than attract new ones. So that's the problem we're going to be working on. And now imagine we've got a notebook, like a Jupyter notebook, that does like some of the very common steps in machine learning process, such as data loading, feature engineering, data cleaning, model training, and model evaluation, right? So I'm pretty sure that most of you have done that kind of work in Jupyter notebooks. But at this point, you might start asking yourself like a few questions. And some of those questions may be like, what exactly was used to produce this particular model that you have right now, right? And this question may come from the fact that it's very easy to change stuff in Jupyter notebooks, right? You can easily add new cells, write some code. You can even execute code out of order, which is easy at the same time kind of problematic. Another question you may ask yourself is, can you easily compare many machine learning experiments, right? Let's say you change some hyperparameters of your model in one of these cells and you ran the model training. Then you did that 10 more times. Like, can you compare what you did? And finally, you might wonder, like, will I be able to reproduce all the experiments that I've done later? Right? So we're asking those questions to ourselves because we typically have certain goals that we want to achieve. And I'd like to present at least 3 goals that I think about when I work on machine learning project, like in this type of scenario. Obviously, the primary one is that we want to achieve the best possible performance. That often means running many, many different experiments or iterations. And an experiment in this context, what I mean is a very particular combination of code, data, and configs, right? These are the 3 components that go into producing a model. If you change any of those things, if you change the code, like that could be the code that does data cleaning or data pre-processing, it could be a code that defines your model architecture, or if you change anything about your data, if you change anything about your configurations, that will result in a different model. So we need to be able to keep track of that. The second goal could be ensuring reproducibility. And why would reproducibility be important? I can think of at least three reasons. Primary one would be, again, from the point of view of improving model performance, because you cannot improve what you cannot reproduce, right? The second one could be from collaboration and transparency point of view. Like imagine if there's several people working on the same machine learning project, and they all want to be kind of up to date on what other team members did in order to achieve certain performance. So that's where, again, reproducibility comes into play. And finally, auditability. That's from the point of view of laws and regulations that may exist in certain industries. Think about questions like if you work in healthcare or in finance, like what exactly went into the models that prescribe certain treatments to patients or determine creditworthiness of bank customers, right? You need to be able to reproduce the model that you currently have running in production, because in case a regulator comes in and asks you to ask you those questions, right? And our third and final goal, again, in a professional setting, we typically want to minimize the setup that's involved and dependency on third-party services. Why? Well, many of you have been in a situation where you're not really satisfied with the framework and with a vendor with a vendor-provided solution, but your entire project is so ingrained and everything is kind of so dependent on it right now that it would take a lot of effort and a lot of time to refactor that framework or that solution out of your code. Second reason could be maintenance and cost, because maintaining your own infrastructure for tracking your machine learning experiments and keeping versioning like artifacts and etc., that could be problematic if you just want to focus on your model and not like infrastructure. The last reason could be security concerns, right? If you are sending training data, like training metadata, I mean just like metrics, even that could be a problem. I'm not even talking about the actual data that your model is trained on, but you're sending like metadata to some third-party service. That can be problematic, and maybe you cannot even get it approved from the security point of view. And I'm talking specifically about most, if not the majority of machine learning tracking solutions out there. That's MLflow, Weights and Biases, Comet ML. They at least have two of these problems. And the fact is that it is difficult to achieve all three goals at the same time, right? Just to iterate what we want to do. So we want to generate many experiments quickly. We want to keep track of all the changes to code, configs, and data, because that's what produces our model. And we ideally want to avoid dependency on third-party services to store data, metrics, and parameters, right? And here's an example of the things that I'm talking about, like weights and biases. By the way, don't take me wrong. I think weights and biases is an excellent service. It's very easy to get started. If you just want to try it out, like it's free to play with. But if your project grows over time and you are not very disciplined about like running experiments before you commit all your code, then you may end up in this situation. And what I mean is you're looking at 5 different experiments that all have different metrics, right? F1 score. This is the column that's selected over here. So vastly different values of F1 score. But as you can see, it's the same hyperparameters like max depth, number of estimators. It's all the same across 5 different experiments, but the metrics are very different. So why is that? Was it a different data set that I used to train these for these experiments? Or maybe it was different code that was not really tracked by this experiment tracking framework. Or it could be both, right? That's kind of a problem. So in general, and also weights and biases is a proprietary solution, it's not open source. So in my view, when you're in doubt, go with open source software. There are several reasons to do that. I'm listing 3 of them here. So community and support. That means if you're using a popular open source tool, there's most likely lots of maintainers and even more, a lot more active users of this solution that can help you out when you have a question. Either you post a question on Stack Overflow or in GitHub issues, and someone will surely will help you out within like a matter of hours, if not minutes. Because it's open source software, it's free to use, and it's typically either zero cost or low cost to set up. Right? So that's the second benefit. And finally, because everything about the development of open source software is kind of public, you get to see public roadmap and discussions about upcoming features, what the team is planning to implement, what they're planning to deprecate, etc. So you kind of have that heads up, which typically you don't have when you deal with proprietary solutions. So what I'm proposing that we use today is a combination of 3 open source tools, which is Git, Visual Studio Code, which is a very popular, if not the most popular IDE these days, and DVC. So again, I mentioned DVC is frequently known for data versioning, but we're going to look at DVC from the point of view of pipelines that you can create, machine learning pipelines. So we're going to be using those pipelines for generating many experiments. And we're going to achieve complete reproducibility by versioning everything. So codes and configs are naturally going to go into Git, but dataset models and other artifacts are going to go into a DVC remote storage. That could be a cloud bucket, network attached storage, SFTP, and lots of other storage systems that exist out there. And we're going to use VS Code and DVC extension for VS Code as a convenient UI for experiment management. And with this combination, there's like no services to maintain, and there's nothing to pay for. It's all local, it's all on your machine, and it's all open source. So what is DVC? DVC is a command line tool for data versioning, for machine learning pipelines, and for experiment management. And those 2 last sets of features, machine learning pipelines and experiment management, they come with integrated data versioning capabilities. So DVC is open source. It's designed to integrate kind of naturally with Git, and it's also language, platform, and storage agnostic. So you can use any programming language that you want, even though in my kind of example today, I'm going to be using Python. You can use it in any Linux, Unix, Windows platform. And as I mentioned, you can use pretty much any type of storage you can think of. So what are DVC pipelines? DVC pipelines are a way for us to chain together common operations that we perform when it comes to like training machine learning models, right? And those common operations are typically like data loading, data featurization and cleaning, and then data splitting into train, test, validation subsets, training the model, and then performing evaluation on the model using testing or validation subset of the data. And typically each of those stages can be parameterized, right? And these pipelines with DVC, they can be either like every stage of a pipeline can be its individual Python module, or we can have a Jupyter notebook that basically contains everything at once. In either case, whether it's Python modules or Jupyter notebooks, we would define a DVC pipeline in a YAML file. So it's a simple kind of hierarchical, text file that has hierarchical structure. So if we look at the left side of the screen with individual Python modules, if we have Python scripts that do data pre-processing and then training evaluation, all kind of self-contained and can be executed from command line, we can create stages with those Python scripts. Or we can keep everything in the notebook that we already have and create a pipeline that will execute our notebook. We're using a paper mill tool. for those of you who are not familiar with Papermill, it's also an open source tool that allows you to pass a notebook through command line file, and it will run it top to bottom and produce another notebook with all the outputs inside. So, and what you see on the right side of the screen, that's what I'm going to be demoing today later. Once you have a pipeline set up, and running experiments is just a matter of specifying new parameters through command line interface, or as we'll see later in VS Code. So for example, in command line, I can just say DVC, experiment, run, and then pass the value 120, this new value for a number of estimators in my model, and that trains a new model. If we run a few of those experiments, we can see all our experiments in VS Code with the help of DVC extension. So as you can see here, I've got several different experiments in this table. Columns, like the first couple of columns are the metrics that I'm tracking, F1 score, area under receiver operating curve. On the left-hand side, I have parameters, so I can compare kind of which experiments result in the best performing models. So enough talk, let's do a live demo. So I have this repository on GitHub that's public. I'm going to share it with everyone in the chat. And I also launched this repository in VS Code. So as I said, our toy problem today is predicting churn at a bank. So we've got this CSV data set. I can zoom in. I don't know if it's very readable, but there's different features of customers, such as credit score, geography, their gender, age, their estimated income, and finally, the last column called exited is a binary column. It shows whether a customer left the bank or stayed with the bank. And for those of you who have used DVC before, you might have noticed that there's a .dvc file with the same name. That is because I'm versioning this data, not with Git, but with DVC. But that's not what the today's talk is about. So let's take a very brief look at our notebook, right? So I'm reading my data here, reading specific columns that I've selected. I can set my hyperparameters. Again, this is what the data looks like. Doing some basic data exploration, data pre-processing, splitting it into train and test, do model training. I wanted to add support, like I'm supporting two types of models, random forest and light GBM classifier. Finally, saving my model and also producing confusion matrix and metrics such as F1 score and receiver area under receiver operating curve. And then finally, I'm saving those metrics into a JSON file, metrics.json. So that's all my notebook does. And I created a pipeline, as I said, out of Papermill and DVC. I created a pipeline. And now we can see kind of in this table, so far, I have what's on my workspace, right? On my local workspace, those are any things that are not yet in Git, but I don't have anything changed right now. And I'm on this branch called one stage pipeline, because that's what my pipeline looks like. It only has one stage that runs my entire Jupyter notebook. And also can see the last two previous commits on this branch. Now, let's say I wanted to run an experiment. And there are different ways that we can do that. The most convenient one I find is doing it directly through this UI. So, by the way, I should have started off with the fact that this extension, DVC extension, can be easily found in the marketplace for extensions in VS Code. If you simply search for DVC, you'll find this extension, then you install it. And once you install it, you'll see this icon on the left-hand side. And now I can right-click on my branch, say modify and run, and I can start typing the name of the hyperparameter that I want to change. So let's say I'm going to select maximum depth of the decision trees, and I'm going to set it from 5 to, I don't know, let's set it to 12. And you can see the extension automatically runs an experiment with this hyperparameter. So this executes my notebook, and we are done. So you see we've got a new entry. We've got the timestamp. We've got new metrics. So these are my metrics over here. By the way, I can adjust the view and the columns that I see. So let's adjust a few things here. And all right, so I can see the metrics that I got with this experiment. The model type was still random forest. I did not change that, but I did change maximum depth hyperparameter compared to what I had on the branch. So 12 instead of 5. And I can see kind of the improvements that I got. Now, I can also maybe try a different model type. Model type. I'm going to try light GBM. So typically, light GBM is a more powerful model, so we do expect to get slightly better results. We'll see what we'll get there. Okay. Yeah, we did get over a percentage point improvement. So now at this point, I say I like how light GBM model performs, and I am going to do something with this experiment. And there's several options that I have here. So as you can see, if I right click on it, I can apply it to my workspace. Let's try this out. When you apply an experiment to a workspace, what it does, it resets your local workspace to the state of that experiment. So everything gets reset. And by everything, I mean really everything. So the parameter that you changed, obviously, but also all the artifacts that resulted in this new experiment, all the metrics, and also all the DVC metadata that was changed. At this point, if I like this experiment, I can say use light GBM model and just go ahead and commit this experiment into my Git repository directly. Or let's undo this. There are other options. I can say that I want to create a separate branch out of it. So I can share this as a branch. I'm going to say try light GBM model. And this is the name of the new branch that I'm creating. Okay, so it's going to take a couple of seconds. All right, now let's go back to our repository, check out our branches, and here it is, right? Try light GBM model. This is the branch. So now at this point, if I'm working as part of a team, I can simply send this branch to someone else, and they'll immediately see what I did because, well, they can at least they can compare, for example, this branch versus the one that I started with, and they'll see all the differences, right? What parameter was changed, how confusion matrix changed, how metrics changed, and so on. So these are kind of two options of what you can do with the experiments. And also, if you don't like changing experiment parameters through UI, you can totally do that simply by changing parameters in this file, in this params file. Like you could change number of estimators to 20 over here, and then say run an experiment. So you see there's a play button, and we'll run an experiment with the values that I changed manually in this config file. So you've got plenty of options of how to adjust your parameters. And then when this experiment is done, we'll have another entry. So you see we've got like several experiments over here. At some point, when we are done experimenting, we can simply remove experiments that are not needed, because these experiments, you can think of them as ephemeral. They're not persistent. Okay. See. You persist experiments by committing them to your Git repository. Okay, so something's erroring out when I try to delete the experiment. So, but that's fine. I can take a look at that later. One more thing that I wanted to show you is that you can actually do hyperparameter tuning this way. So DVC supports integration with Hydra. For those of you who have not heard about Hydra, I think it's hydra.cc. So this is an open source configuration framework. So it allows for like flexible management of configurations and parameters. And DVC supports that, meaning that you can run, for example, I'm showing you this command that does grid search. So we're specifying DVC experiment run, and then the parameter that we want to change. In this case, it's number of estimators that lives under train params number of estimators. And I'm saying that I want to explore a range of values. So this is just a Python range, values between 50 and 200 with a step of 30. And I want to do a similar thing for max depth for values between 10, 25 with a step of 5. And I want to queue them up. So let me copy this command and just paste that in. And what is going to happen is the extension shows all the experiments, kind of all the combination of pairs of those hyperparameters that I created, right? But there are no metrics. And there are no metrics because I simply queued up these experiments, but I haven't ran them yet. I mean, doing this hyperparameter tuning like right now would take a few minutes, but I could totally start this entire queue of experiments by simply clicking this Start Experiment Queue button. And then after a few minutes, all these experiments will be executed. I'll be able to sort them by the best performing experiment. So when you enable sorting, it automatically kind of floats the best performing experiment to the top. Well, if you sort in descending order. And then whatever ends up being at the top, you just commit to your Git repo as a form of a branch or a commit. Another feature of this extension is that you can visualize different experiments. For example, we can pick like 3 ones over here. So I can compare receiver operating curve and can compare confusion matrices, like whatever plots I list as plots in my DVC pipeline that will show up here for easy comparison. So that's really it. So I definitely hope that you give DVC and DVC extension for VS Code a try, and let us know how you like it. All right, so let me do the quick summary and then we'll get to questions. So, common requirements for machine learning experimentation. We want to generate large number of experiments because that's typically required to achieve the best performance. We do want to version code, configs, and data all at the same time. and we want minimal setup and external dependencies. So the proposed combination of Git, VS Code, and DVC pipelines, I think, addresses all these requirements because we use Git for versioning codes and config. We use DVC for generating many machine learning experiments, as well as versioning large artifacts such as datasets and models in our own infrastructure. As I mentioned, like typically there would be some kind of cloud bucket. And then we use VS Code and DVC extension for VS Code for visualizing and managing machine learning experiments. And again, it's all open source and free to use. So thanks, everyone. Let me see if we got any questions. Oh. 1 second. Let me enter full screen. Okay, I see that Sean is asking, can you try multiple different parameter values from the UI, or is that only possible from CLI? Multiple different parameters from UI, only if you specify, only if you basically generate multiple experiments, right? If you right-click and click modify and pick a parameter. But if you want to do a sweep of parameter values, then you have to use CLI. So I hope that answers your question. Okay, yeah, you mean grid search from the UI? No, you cannot do that right now, but that's actually, I'm going to take it as a feature request, and I'm going to pass it along to the team that's working on this. Okay, so, all right, the question about large data sets. What would you do if you had to scale up to large data set and cloud runs? How would you switch between development and large runs? Excellent question. There's actually another tool that complements DVC very, very well. And this tool is called CML. So what is CML? CML is open source command line tool, but it's not designed to be used kind of during development. It's designed to be integrated with CI tools such as GitLab CI/CD, GitHub Actions, or Bitbucket pipelines. And the benefit of it is, let's say, so we are using GitHub today. So I'm going to switch to this example over here, maybe to a simpler one. So what it really allows you to do is produce basically every time, for example, you push to your repository, it can install all the dependencies for your project. And then run your model training code. And then you create a markdown report. Like you can put whatever you want in there. Typically, you might want to put some model metrics in there, some plots, like a confusion matrix. And then you publish this report with CML. And then you see kind of, for example, if this person changed some hyperparameter, we can see that, okay, it's over here, I think. So this report is going to be published automatically as a comment to this commit. So why is that relevant to what you asked? And the reason is, with CML, you can also provision runners. So because in GitHub Actions or GitLab CI, I don't think you can provision like GPU runners or runners with like tons of CPU cores. But you can do that in AWS, GCP, or Azure, right? So you can simply say CML runner launch, specify your cloud, and the instance type, right? And that's up to you how you want to specify it. And then you can also optionally provide like the size for a hard drive and the type of hard drive. So you can provision a huge machine with tons of space in it, and the rest of your pipeline will run on that runner that CML provisions. So that, I think, how that addresses your questions, that if you don't have enough local space on your machine, or your laptop is not powerful enough, you can provision a machine with a GPU or multiple GPUs, or I don't know, 50 cores, 100 cores, with like a terabyte of disk space. And with DVC, you can simply bring that data onto that runner, run your training, and then publish the result as that commit. So that allows you to run your machine learning experiments through your CI tool of choice. So does that answer your question, Lavi? All right. A related question, is it possible to use ML from cloud builds? So cloud builds, I'm not familiar with it. I'm going to assume it's a CI tool in GCP. Unfortunately, no. So GitLab, CI/CD, GitHub Actions, and Bitbucket are the only CI tools that are supported right now. But tools that are CI tools that are provided by cloud vendors, such as Cloud Builds and Azure DevOps, the support for them may come in the future. Right. Any other questions? Does DVC support consuming data in parts? Okay. One chunk at a time. No, it doesn't really. It kind of brings, like, if you version a data set, it brings the data set to your like local workspace or to that CI runner all in one. Like, it doesn't do streaming, if that's what you're asking. But I think I kind of get your use case, right? If you're doing deep learning, you might want to sort of prefetch a batch of data from like a cloud storage at a time, right? Before it's fed into GPU. Would that be your use case? Okay, and also sharding between versions. Right, that's kind of a very specific use case. Maybe if there's enough demand. So definitely you can describe your issue in a DVC repository. If it's a valid use case, it can get implemented. So I would post the link to DVC over here. Right. Any other questions? Okay. If there are no questions, I think we can wrap it up. Again, I'm going to share a link to this presentation. So these are slides. I'm going to share a link to the repository. And finally, since the question was asked, I'm also going to share a link to CML. Okay. Thank you, everyone. And if you have any questions about DVC or CML, definitely reach out to me. My social media handle is Alex000Kim. So I'm on Twitter, LinkedIn, or GitHub, however you prefer to reach out. All right. Enjoy the rest of your day, everyone. Thank you.